The question is like that. Suppose a worm gear is there. Hmm. Suppose uh, one gear. Hmm.
इसका इसका क्या बोले मेसी का रिक्वायरमेंट का
तो सही बात है ना, वो अब कुछ मैंने पूछा, कल भी
चेयरमैन से
पूछा।
बात करके
हाँ कल भी पूछा, बोलते मैं बात करूँ। See, actually, in case of worm gear, what we have to do now, first one is there have the linear shaft on which there have the thread, okay, and that is you can say in such a manner. It is there in such a manner. Actually, the thread is there, and one wheel is there. You can take a wheel. Suppose this wheel is rotate in this direction, okay, and from the center this is the radius. Now in question, if it is given like that, a worm, a b, this is called actually worm gear, worm gear, this one called the worm wheel, okay. So suppose a worm gear, if we denoted it as a AB, which have a radius, suppose it have a radius of 1.5 inches, that is the R, admit all, which is 1.5 inch, and a lead, have you remember the, and a lead, remember in the screw na, that is the, this is the actually the thread is like that. So from here to here, that is called the one lead, or you can say from here to here, both, so that is nothing but L is equal to, given is 0.375 inch, okay, clear. And the friction coefficient, static friction coefficient is given 0.12. Then the question is, determine the couple moment that must be applied to the shaft AB to rotate the worm wheel in the counter clockwise direction. How it will come? So the worm will rotate in counter clockwise direction, okay. Try to understand this thing, that find out the amount of moment that is required, where we have to apply that moment on the AB. One thing you have to understand, this is the worm gear, this one is the worm wheel. Remember, this one is always the driver actually, okay. So we have to apply the moment always on the shaft AB, clear. It is not possible, remember, it is not possible to apply moment on the worm wheel so that we can rotate this worm gear. It is never possible, because it is always working principle is on the self locking mechanism. So you have to always apply the moment here, okay, so that it can move. Hmm. Now the question, if it is like that, then what we have to do? A simple, first draw suppose one means one rotation means how much it is. One rotation is nothing but the 2 pi r, right? So if you draw that 2 pi r amount, then you apply, suppose this one is your position and they are the load, na? Same, na? Previous one I draw this type of thing, right? Means that is the equivalent diagram. So if it is like that, and in as per the question, as per the question, suppose you have to you have to work on there. So that is nothing but the given, it is 77.2 and the divided by 12. Okay, because 12 is the given radius. This one I am talking about, this one. Hmm. Another thing is, means you have to rotate this thing, na? So the minimum requirement for that is nothing but the, here to apply that moment, the work done that is required, that is the actually 7.2, what is that called, 7.2 kps into r, so we can say inch, kps into inch, 7.2 if it is, then it is given actually in question. Then w is 7.2, means w is the weight actually. Hmm. That is how much? 600 pound. Okay, so that is the applied on the here, this one. Okay, now as it rotate, so first we have to find out that if this is 2 pi r, hmm, just means we just rotate this portion, this figure we just rotate in this direction, so this is 2 pi r. Okay, and this one is the your l, lead. Hmm, means here it is l, and just rotate, na, this figure if we just rotate, then w is the upward side, so w, and this one is the your q, right? If it is, then this is the theta, one lead. If it is, then one lead is how much? Theta, means this angle, this angle. Hmm, this is theta. So if we want to find out first one, the frictional angle, that is what frictional angle. Frictional angle is nothing but, if we say phi, it is nothing but the tan inverse of mu, na? So here, why at the phi s? Because it is given in the question, that is a static coefficient of friction. So the static frictional angle is nothing but phi s is equal to tan inverse of mu s. So mu s is given 0.12. So tan inverse of 0.12 is the phi s, this angle. So what is this angle? Phi s is equal to tan inverse of 0.12. How much it will come? How much it will come? Hmm? Reply anyone. Tan inverse of 0.12. I think approx how much it is? 7 degree, no? So consider approx 7 degree, I guess. So now coming to the point, that is we have already drawn the mute yourself. So this is the weight of the worm wheel. This is the angle. So you know that this one have some angle with this. So this is also theta, and the resultant which is acted have some angle. So that one is the phi, right? So here it is phi s. This is the resultant. Now, if it is the resultant, then if we draw, this is actually W is 600 pound lbs, and here it is given that is the Q is this one, and this one is your resultant, na? And resultant is angle with respect to vertical axis, that is nothing but the theta plus phi s. So this angle is how much? Theta is how much? Theta is, we can easily find out from the lead, na? Because this is one lead. So this L is nothing but given in the question 0.375. So tan theta is nothing but the 0.375 divided by 1.5 into 2 pi, because it 2 pi r, na? This is tan theta. Tan theta is this one and this one by this one. So this is 2 pi r. R is 0.15, sorry 1.5, and L is 0.375. So theta is nothing but, from here we can get is 2.27. Okay, so if we add these two, 2.27 and 7, 2.27 plus 7, you can calculate yourself actually. This may be 7 or something, this may be 2.2 to 2.5, in between that. So it will come the value, what the value will come, what we have to put, we have to apply the simple uh, Lami's theorem we can apply. So from Lami's theorem, if we apply, then we can get that 600 means Q divided by 600 is nothing but the tan theta plus phi s. Same, you can Lami's theorem or you can apply the tan formula, both you can apply. So from here you can get easily that Q is equal to this amount. And now in the question it is given that how much torque is required to rotate the worm gear. So the torque is nothing but the Q into worm gear radius, na? Worm gear radius. So that is Q into 0.15. No, sorry, 1.5, no? That is 1.5. So you can get the torque. That is your answer. So up to this, anyone have any query? Up to this, anyone have any query? Or should I repeat this one? Which one you needed? Hello, is my voice audible, student? Hello. Hello. Anyone have any query? You can ask. No issue. Shall I again repeat this problem?
Yes, sir.
Okay. Okay. See, means you question is understandable, or I have to repeat again the question actually. Hmm?
Once repeat, sir.
Question also means, have you understand the question or no?
No, sir.
Okay. Okay. See, in the previous day we have already discussed about the square threaded screw, na? So in square threaded screw, actually when we just how can I, okay, uh, you remember na, that previous day I just shown you that this is a square threaded screw, this is a space where if a load is there na, this type of thing I already discussed with you previous day. And if we draw the equivalent diagram, then we have made this type of thing na. This one remember or forgot? Previous day, there this one is the W, and as there have some thread, so between these three nut and the collar there have some friction. So the amount of load which is acted on the collar, that we denoted as a Q. Here it is the weight of any component, that is W. And as this is the thread, na, this was the thread angle na, theta, means here it is given na, in the previous day I discussed with all the thing na, that these are the angle with respect to horizontal axis. So this and the resultant normal, if it is normal, and if it is the your friction force, then your resultant in this direction. And if you want to move your body, or this is your body slope with respect to this slope with respect to upward, then your normal is this one and friction is in this side na. I discussed this thing, right? And in that case your resultant is in this direction. So that's why some cases it is means when your body move downward, the friction is in the upward. When your body tends, you want to move your body in the upward direction, then your friction is the opposite direction na. I discuss about this thing. So same concept actually we have to apply for the present calculation. And the present problem is like that. See, a means just try to understand, this is a simple to means gear. Okay, don't try, this is not a very heavy things, this is very simple. Suppose you all know that gear is in circular manner na? So, and there have some teeth on the gear, right? Like that. And as I already discussed with you, that is a square thread, so there is a square thread, huh? If it is, now actually the question is like that, you have to apply. And one thing you have to understand, that it is attached with the another gear, huh? Another gear, and there have also the thread. Okay, and the question is, you have to apply some moment or torque on this gear, that is called the worm gear. Okay, now how much torque you have to apply? In question actually it is given that here means it is connected, actually it is connected with another shaft. Okay, that is not your actually the problem, means it's connected with another shaft. So there need actually the moment, and that moment is given as a 7.2 k pascal inch. Okay, it is given in such a manner, KIP IN. So it means how much torque we have to apply on this worm gear, so that this worm wheel can get this amount of moment. Understand or not? The question is how much moment we have to apply on this worm gear, so that 7.2 kilopascal inch moment or torque applied. Now it is understandable. Please reply anyone actually, please.
Yes, sir.
Means the question is the amount of moment which is need. The question is find out the moment or torque. You find out the torque, how much we can apply on this worm wheel, so that actually it will rotate. This is the driver, this is this gear rotate this gear. Okay, so when it will rotate in this direction, this will rotate in this direction. This is a worm, this, and this set is called actually worm gear set. So the question is find out the torque, means find out the amount of applied torque which is needed. Q, why it is needed? Because to generate or to provide or to generate 7.2 amount of moment in this shaft. So these will have certain radius given in the question, that is 12. So what is the load then? Load, if we consider load as a W, load is nothing but 7.2 divided by radius. So it is nothing but 6000 lbs, as it is a kilo na. So we 7.2 is nothing but 7200 divided by 12, 6000 pound. So it means we have to apply such a torque so that it can, means worm gear can rotate a worm wheel, these on which have a 600-pound load. Understandable? Means this worm wheel is connected with a load of 6000 pound, and we have to rotate this one. So how much torque is needed to rotate this one? Question is clear?
Yes, sir.
Okay, see, next is what. So for this, what we have to do? I already told in the previous lecture that if the square threaded concept is like that, means if it is this type of things na, so we have to convert it in the equivalent figure. So here also similarly we have to convert it into the equivalent figure. So equivalent figure is, for this case we have to understand that you actually, when you start this problem, then you apply a load. Okay, when it will rotate in this direction, then the load is applied on, means this connection in at the interteeth connection, right? It means in for the present case, the load is acted on this wheel in this direction, right? Or we can say in this direction. Is it clear? Normally in the previous lecture we have told na that one jack is there and load is applied here, but in the present case the load is acted where? This interteeth position, because it will rotate. These, if we say A and B are the wheel gear, worm gear, and if this worm gear try to rotate this worm wheel, means circular one, so where the load will acted? The load will acted on this junction, na, interteeth meshing position. So if it is, then the load is acted also at that position only. Is it clear? Up to this, is it clear?
Okay, sir.
Okay, means it is not clear till now. Hmm? See, means try to understand this portion actually. This is your worm gear. You want to rotate this worm wheel. Huh? And this worm wheel, when it will rotate, actually, the question, it is given that 7.2 kilonewton, if it is provided, then only possible to rotate this worm wheel. This is actually very big wheel. Huh? If you apply 7.2 moment, then only it is possible to rotate. So the question is, how much torque is needed to rotate this thing? Now, how it is possible to rotate? When that two gears are in meshing, and meshing when it is possible? At this junction, na? This junction. And when the meshing is there, there have loading. Means one, suppose one gear is needed this amount of kpsi na, so this amount means 7200. This is very high, so this amount of moment is needed for this wheel. So it means there have the, at the junction point there have a huge load na. Understand? Huge load. So that load is we define as a w, which is nothing but 6,000 pound. Here 6,000 pound. Up to this, is it clear?
Yes, sir.
Any confusion you can ask. Actually, I could not understand your confusion, so that's why I am repeating again and again. If anyone tells us that this one actually could not understand, so I think it is better. I will clear your confusion. Any confusion is there. Up to this, is it clear? If anyone have any confusion, you can ask, no problem. Please tell anyone. So
Clear,
should I
sir.
go ahead? Continue.
Yes, sir.
Okay. So see, the as the loaded acted on this junction, so that's why it is the load that is a defined as a W. Now, if we draw the equivalent diagram for this case, that is nothing but this is your W. Okay, and this is your, means this what is called worm gear. If this worm gear is rotate, it means one full revolution. If we just make linear, then this is nothing but the 2 pi r, one full revolution. So one full revolution, how much load will acted? And previous case we already discussed na here, previous classes, that this one is a q, right? Previous one means that from the thread. I think you may forgot, I think. See here, I think have you remember this one, that applied force p, this one you have to rotate in this direction, and here have the thread. So the amount of load acted on due to this meshing, so that is the q, and this thread have a radius that is r. So q into r is nothing but this applied force into distance. Remember na this thing. So I am talking about that q, means the force which is generated or acted on the interteeth due to the reaction. We can say this is the come from the meshing. So that is the q for the present case. Okay. Now, as previous lecture, we have drawn this in such a manner na, that q is here, w is here. Just we want to match with this. So what we have to do? Simply just rotate this figure. This figure just rotate. So if we rotate this figure, then what we get? This, and this. Clear? This is 2 pi r. This one is the lead L, and this one is your W, and this one is your Q. Now it is equivalent na, with our conceptual square thread design. Equivalent, right? This is Q, this is W, this is theta. So this is Q, this is W, and this is your theta. Up to this, clear? Step by step, I will ask you and just tell me that where your confusion, huh? Up to this, is it clear?
Yes, sir.
Okay. Now, see, this is your thread na, for worm gear, this is your thread. If we neutral means equivalence, we can draw this type of thing, na? Same thing, means this is your pitch or lead. So here also this is your lead. Same. So that lead is how much? It is given in question 0.375 inch. Okay. So the tan theta, if we want to find out the tan theta here, tan theta is L divided by 2 pi r. So L by 2 pi r. So r is given 1.5 and L is given 3.75. So we can easily find out the theta. Right or wrong? Is it possible, right, to find out the theta easily? Please reply. Up to this, is it okay?
Okay, sir.
Now, so we can easily get the theta here. Now, another concept is there, that what we have to do, we have to means try to move this block in the upward direction. Okay. So in that case, you know, this is your normal. In the friction, this is your normal. So this one your normal. And if you move your body, in the means this, due to this load actually of this body, due to this load means 6,000 pound, na, these have a tendency to move in the downward direction, have a tendency, right, to through this slope. So the friction is in this direction. Clear? If the body have a tendency in the downward direction, so they have the tendency in the friction upward direction. But at the same time, you have applied the Q, right? So it means you want to move this body in the upward direction, whatever the load is. Means suppose if Q is not there, then this one your normal, this one is the frictional force. Now as Q is there, means this is your applied, so Q is there, it means you want to move this body in the upward direction. Okay. So your frictional force is in the opposite. If it is, then which one is your resultant in this direction, and this one is your phi s, right? Very basic, means fundamental concept of the friction. So this is your resultant. So we have to put a resultant here. Up to this, any problem, anyone? Up to this, is it clear? Any confusion regarding concept? Please reply anyone. Up to this, is it clear? Any question?
Clear, sir.
Clear, na? So now just draw the force triangle, that this is your W, downward direction, which is given 6,600 pound, right? This is your resultant, and this resultant is create a angle with respect to normal, that is phi s, and the normal create an angle with respect to vertical is theta. So this one is nothing but the theta plus phi s. Now if it is r, w, if it is q, then tan theta plus phi s is nothing but the how much? Tan theta plus phi s is nothing but the how much it is? Tell me. Six hundred divided by Q, right? Clear, na? Or Q divided by 600. Which one? Tell me. This is your angle. This one is your angle. So tan theta plus phi s, this one or this one?
Q by 600, sir.
So tan theta
So
plus
tan
phi
theta
is
plus
Q by 600. So you know the theta, you know the phi s. Theta is where are you? Oh, theta, yeah, theta is tan inverse of 0.375 2 pi 1.5. This one is the theta, and phi s is how much? Phi s is nothing but the tan inverse of mu s, right? So mu s is given 0.12. So from here you can get the phi s. So put that value in, multiply with 600, you can get easily Q. Now in question actually they ask how much torque is required. So torque is nothing but the Q into the radius of worm gear. So worm gear radius is how much? Worm gear radius is 1.5 inch as per question. So that Q in multiplied with 1.5 is the torque. So that amount of torque is required to rotate the worm gear, so that the worm wheel can move, or the worm wheel can withstand this 7.2 amount of moment. Now it is clear. Please say if anyone have any confusion, you can ask. Anyone have any confusion in this problem? These are actually important, so that's why I am trying to means make you understand that if anyone have any confusion, you can ask, sir. Yeah, it is not possible for me. Please explain again. Then I can explain. No issue. Is it clear up to this?
Yes, sir.
Okay. Then can anyone tell me how many types of friction problem I have solved? Anyone have any idea? I think I give a lot example, na? Hello. Now I think you can solve, right? So next day I will start another wage, and see I already solved this type of problem, na? That one wage is there, another wage is there, want to move, na? If it is suppose a block. Now if anything is there, any rotating body is there, then I think this type of problem is not solved, na? Previously, is it solved previously, that any
No, sir.
rotating body and they have a wedge, apply a force, how much it is required, this type of problem, then we will shall discuss in the next lecture. This problem has been solved, na? This one, right or wrong? I have given the concept, na, previous classes, I guess, previous or day before previous, that how much, what is the frictional force in between two surface, how much load is act and need to act to move this body upward or to lower the body. Have you remembered this thing or forgot everything? Hello, please reply. Whatever I have written, please try to write also yourself, so that you can. It is possible to remember. Otherwise, how you can remember? Whatever I just taught to you, you just listen and then completely remove from your mind. Then it is not possible, na? You have to minimum have to remember something. Okay, so I end my lecture here. Try to solve. I give one home task. Try to solve uh, this problem at home. Suppose similar type of problem I have given, which I have already discussed. Na? Similar type of problem, no issue. Same. Suppose this is a 400 pound. Huh? This is wall. This is another wall. So you have to find out the minimum amount of P to maintain this one in a, what that called, to rest at its position. Means you have to apply the minimum amount of force which is required to maintain the equilibrium position. Okay, so find out the amount of P and consider the friction between all the surface here, here, na? All the surface have friction, right? Here, here. So consider all the surfaces, the friction mu is 0.25. Very simple for you. If it is different friction, then maybe you can do for separately. But now I think you can do this math very easily. Try to solve at your home. Huh? I already have given the concept on this in the previous lecture. So please try. Okay. So today I end my lecture here. Anyone want to say anything? Okay. Then I end my lecture here.